So dear students, welcome to the advanced CAD for application class. So in this class, we'll make an axial fan. Okay, what is the axial fan? So axial fan, when we consider means when we consider a fan shaft, okay, fan shaft, and this is the axis of the fan, central axis of this fan, and fan consists of some blades, right? Fan blades. Okay. So if the fan consists of blades, and if the air direction, so fans are used to supply air, right, with some flow rate. So if the air passage direction is parallel to the axis, okay, parallel, this is axis, and air passage direction is parallel to the axis, so that fan is known as axial fan. Okay, axial fan. So most of the fans we are seeing are axial fans. Okay, so axial fans are used for high flow rates. Okay, high flow rates, so high flow and low pressure applications. Okay, there are some other fans, okay, like centrifugal fans and blowers. Okay? So those fans are used for low flow rates and high pressures. Okay, low flow rates and high pressures. So but here axial fans are used for high flow rates, and the flow direction, air passage direction is parallel to the axis. So another term for axial fan is also propeller fan. So propeller fans, if the fan size is very big, so then we say that one is a propeller fan. So the propeller is, this one is like propeller. Okay, so this one is known as propeller, entire this one. Okay, entire the fan unit is known as propeller. So propeller fans. So in case of propeller fans, yeah, today we will consider two designs. Okay, one is just a blade shape. So yeah, so this is the side view of a fan, right? Side view. So when we view from the top, okay, top, if the blade shape is like line, we consider one application. So we draw so one figure, and if the blade shape is like aerofoil shape, okay, aerofoil, I mean when we move from the top, so if the blade look like this one, so this shape is known as aerofoil. So aerofoil shape. So the coordinates of the aerofoil, we can get the coordinates of aerofoil from NASA website, okay, and copy these coordinates, points, into Excel file. Okay, copy these points to Excel file, and we can import those points from the Excel file to CATIA, okay, by running some macro, right? So you know how to run a macro to import point coordinates from Excel file to CATIA and point lines, right? Yes. So for making axial fans today, we have to use these tools. So one is projection and blend and extract. Okay, so projection and blend we use. Okay, projection and blend we use for making the line shapes. Okay, and for propeller types we just use projection and multi-section surface. Okay, so yeah, so projection and blend, if you want to use generative shape design and go to part design for remaining thing, so these two tools are enough. Okay, these two tools are enough. So you will see what I mean when we do. So yeah, but if you want to do completely in generative shape design, everything in generative shape design completely, we have to use these three tools. Okay, these three tools: projection plus blend plus extract. I mean complete generative shape design for fan. I don't want to go to part design again. Okay, yes. Yeah, this how to work with these tools. So open generative shape design, generative shape design. So start mechanical design, shape design, and generative shape design. So give the name. Yeah, projection. So you can see the projection. Projection is here. This one in wireframe tool. So point, line, and plane. So you can see the projection here. Okay, projection. So the projection is here. Okay. So what is the projection means? The projection is, suppose I have a surface like this one. So I have a surface like this one. It can be a round surface or flat surface. Okay, a cylindrical surface, round or flat surface, or a spherical surface. Okay. So, and I have a sketch like this one. Okay, somewhere else, not on the, okay, not on the not on the surface, somewhere else I have sketch. So I want to project this sketch. Okay, project this sketch onto this surface. Okay, maybe when we project this sketch to the surface, the shape may be different. Okay, so then we use projection. So there are two types of projection. One is normal direction, along the normal direction, and another one is along some direction. Okay, so normal direction means project at exactly 90 degrees to the surface. Okay, so project sketch exactly 90 degrees to the surface, then we call that one is a normal type. And along direction means we can specify some direction, right? Not 90 degrees. Okay, 90 degrees means just normal. Okay, 90 degrees is normal, but if you want to project some other angle, maybe 60 degrees, okay, 60 degrees, we have to draw a line or sketch, or we can select some axis, x-axis projection or y-axis projection or z-axis projection or random direction. Okay, you have to draw some line, okay, line or axis for projection, and you can project along some angle, some inclination, okay, 60 degrees. So then the resultant projected surface is like this one. Okay, so let's see this one. Okay, here. Yeah, I want to first create a cylindrical surface. Okay, cylindrical surface means round surface. So I'm using cylinder for that one. Cylinder. Okay, cylinder. So this cylinder is here. Extrude, right? So if you expand extrude, you can see the cylinder here. Cylinder. I'm not drawing sketches, circular sketch and extrude. I'm directly cylinder. Okay. So we need a center point of the cylinder. Center point is not created, right? So right click to create a point. Right click there. So create point. So 0, 0 is a center point. 0, 0, 0 is just origin. Okay. So that is the center point of the cylinder. And the direction. So axis direction. Cylinder axis, a central axis, x direction. So in this case, x direction, right? X direction. So x direction, x component, and so radius of the cylinder maybe 50 millimeter, and I want to use mirrored extent. Okay, so mirrored extent means sorry, radius is 50. So radius is 50 and this length is 100. So 100 one side and another 100 other side. So mirrored extent. Okay, and yeah, from I want to project some sketch, right? So draw that sketch on some plane. So not on XY plane, so some other plane. Okay, maybe above that cylinder. Okay, yeah, draw sketch. Sorry, create plane first. Okay, create plane from that XY plane. So create some other direction, maybe 60 millimeter or 80 millimeter. So to make sketch for projection, and so draw line, spline or line or anything you can do. You can use anything. So line or spline or some arc. Okay, I'm using spline here. Okay, spline, and I want to project that sketch. So exactly normal to that cylinder. So default option is normal. Okay, So then I select this one, okay, project. I deselected the sketch and project. So normal type, which one to project? Project this one, right? This spline, like the snake. So on where? On this support, on cylinder. Okay, so this is the project and support is here, and this is the support. So click on OK. Okay, click on OK. Yes, this one is just sketch, and this one is the projected sketch. Okay, so I projected the sketch on the cylinder. Okay, so okay, that is the projection. And here this one is normal type, and you can also choose some angle projection. Okay, so for angular projection I'm making line here, okay, around so 60 degrees line. So 60 degrees line. So where? On YZ plane. Okay, on YZ plane, draw some line. Okay, 60 degrees is too much, so 20 degrees line. Okay, so that is line. And here I want to project this one at an angle 20 degrees, okay, to the surface. So project this one, projected, and support is this one. Normal type is we have to choose along a direction. And sketch 2 is a projected sketch, which one I want to project, and support is this one, and direction is along specific direction. Okay, so both are different, right? At an angle, some an inclination angle. Okay, so this one is normal type projection. Okay, this one is normal type, and yeah, this one is along direction type. Okay, so that is the projection.